with lots of different types of cells. In fact, in culture, you have the ability to more precisely control the content of meat than you would in a live animal. So you could have mixtures of different cells, and instead of having, say, really high saturated fat, you could actually have the good kinds of fats in meat that we know protect health. So having omega-3 fatty acids, say, in your hamburger, you could actually have a hamburger that prevents heart attacks rather than causing them.
Boy. Well, what are the big advantages of culturing meat this way as opposed to just letting animals grow?
Well, I'd say the principal advantage is for public health. The fat content in animals is unhealthy. In vitro, we can control that fat content directly and have meat that's much, much healthier. A second public health benefit is that farm animals are actually the source for many new infectious diseases. So if we produced all of our meat under sterile conditions in vitro, we would prevent those kinds of diseases, and we would also prevent the foodborne illnesses like Salmonella, Campylobacter, E. coli that threaten our food supply. A second major benefit besides public health is environmental quality. Right now, meat production causes more greenhouse gas production than the entire transportation sector combined. The last benefit is that you could address the animal welfare problems that have surrounded meat production, particularly since the end of World War II. So right now, for instance, in North America, most chicken production takes place in factory farms where you have tens of thousands of chickens in a single metal shed. It's not a healthy way of producing food, but it's also not a humane way of producing food.
You mentioned that you're only doing it on a small scale. What about the cost of doing this?
Yeah, right now it's just not feasible to produce it at a large scale using the technologies that were developed for biomedical treatments. So what's been done recently, particularly in the Netherlands, is looking at ways of making the tissue much, much cheaper. And ultimately, we're quite optimistic that within, say, the next 10 years, those technologies will become sufficiently cheap that they'll be competitive with regular meat.
Do you think the public would accept a product that's grown in a laboratory or in a vat?
So I think the real stumbling block for consumers is going to be, first of all, kind of the Frankenfoods concern. And there, I think it's important to compare it with the way regular meat is produced. There's nothing natural about raising 10,000 chickens in a metal shed and doping them full of growth-promoting drugs. The real question is, can we produce our meat in a way that's much safer, that's much healthier? We've had bioengineered foods for millennia. Cheese, bread, wine, those are really bioengineered foods. Yogurt, that's a cultured food. We already eat lots of historically novel foods and accept that they have many advantages.
Mr. Matheny, thank you very much.
Thank you, Bob.
Jason Matheny is with the Bloomberg School of Public Health at Johns Hopkins University.
Interview 2 is now over. Interview 3 will begin now.
One huge problem we'll be facing in the future is weaning ourselves from our dependence on fossil fuels. More than 85% of the energy we use for electricity and transportation worldwide is produced by burning coal, oil, and natural gas. This, as you no doubt know, is leading to potentially disastrous climate change. Now, there are lots of potential alternatives, but the one that's raised a glint in scientists' eyes for half a century is fusion power. Many researchers think that fusion, which is the reaction that powers the sun and the thermonuclear bomb, has the potential to supply a vast proportion of our energy needs, cheaply and relatively cleanly. One of those researchers is Dr. Michel Leberge, a physicist and the president of a Vancouver company investigating fusion technology called General Fusion. Now, Dr. Leberge, there's a joke I've heard from people skeptical about fusion power who say it's been 50 years away for 50 years. Now, why is that?
Well, it's a difficult thing to do. The big problem with fusion is that what you want to do is to fuse those two nucleus together, and they're both electrically